So moving forward, guys. So yeah, your first day or first week on a drill site, excellent. Thank you, Rana. It can be a pretty intimidating place when you first arrive with all various machinery and things, and it's normally in a relatively remote location as well. So there can be lots of noisy equipment, and there's also no shortage of hazards out there. Okay, so there's plenty going on out there, and things that do have the potential to cause harm. There can be a lot to take in with lots of moving parts and things like that as well. Various team members moving around performing their tasks as the drill crew. And I imagine as a new geo and things on site, you really want to know where to be and where not to be. And also with all that going on the surface, you guys also need to understand what's happening below your feet in regards to the geology that's being drilled, the techniques that are being used, and what to expect out of the geology as well. And then you guys out the back end need to make sense of that in the labs and with various reporting and things like that I've been listening to from previous providers. So how does it all work? And also what's available to you guys to achieve your goals, your drilling goals. And I just hope that at least a few people today walk away with a few pearls of wisdom, I suppose, or a few nuggets of information that you may not have known about the drilling industry as well. So what the space that we play in as drillers and the rules and regulations we need to abide by as drilling professionals out there in the field. So yeah, a couple of light bulb moments, hopefully, that you can take away from today. So when it is your first time on the drill site, your number one priority out there should always be the safety, your safety, and safety for yourselves and for everyone else on site. And then in this sequence as well, safety for yourselves and any other personnel, the environment, then the equipment. Okay, in that order. And that's the way I operate for my personnel, and anyone who steps inside those cones or that delineated drill site, I ultimately take responsibility for those people, and it's on me to make sure that I offer a safe workspace for anyone who enters into that space. Common hazards on the drill site. I'm not sure. There's plenty of hazards out there, but there's lots and lots of hydraulic hoses, hydraulic hoses running through the drill, and these things are running at really serious pressures, 7,000-8,000 psi. And these things really do have when they do fail, they have the potential to cause some pretty serious harm. Another one as well, which I think is a big one, especially in mineral exploration, is high pressure air for any sort of rotary air drilling methods as well. There's some pretty big units out there that can produce a lot of PSI and a lot of volume of air as well too. So it's something that's not to be sort of messed with, and a high level of respect needs to be given to that equipment and its safety and its use. But along with that, with this equipment running, the noise, sonic drilling can be particularly noisy, or compressors running, things like that. Yeah, there's no end to the different decibel readings that you'll be exposed to, so correct PPE around those hazards is critical. We've also got water pumps going. There is hydraulic pumps as well to push that oil around. Then you just add on all the others. There's the dust, there's contamination from downhole. Spent a lot of time drilling landfills and things like that as well. So there's even been cases drilling through medical waste and things like that, but that's in my environmental and geotechnical space. So there's all sorts of things to uncover and protect yourself from, but very common. Drilling down in Tasmania recently in the beautiful Tassie, the cold down there can be quite biting, and you need to look after yourself in that aspect. But flipping over to other operations that we have running today, we're 3 hours east of Darwin as well. So we've got some pretty serious temperatures to deal with up there. Hydration. We also talk about diet with our people as well. So consider these things where you're moving throughout Australia or throughout your career. Always consider the weather that you're going to be in and how you're going to look after yourself with those environmental aspects or hazards, so to speak. With drilling as well, it can be a very isolating profession. You can be very remote. And yeah, looking after yourself, making sure that you've got your home life squared away and that you're well enough to go away and you're in a good headspace to go and do your 1 week, 2 week, 4 week swing, whatever it is, but just mentally prepare yourself, because that is I guess a mental hazard, which I think anyone who's been doing this for a period of time would have come up against those challenges before of being away when you really want to be home. So just having that in check and making sure that your upstairs business is looked after as well, because it can get on top of you, especially in remote locations. Okay, the list goes on and on and on. There's no end of them. So we've got to learn what the controls are. How do you identify the hazards on a drill site? What we do, and what I believe any good drilling company should do, is they should meet whoever a new entry is at onto site. They should ultimately go and meet that person at the entry point to the site. They should use the driller. They're the best resource on site. They should be the most well educated in regards to all of the hazards and the controls associated with those hazards around their equipment. Right, they're ultimately responsible for all personnel and equipment who enter into that drill site. We know we've been invited into that area either by you guys or other clients and things like that. But when we delineate our area, we really take ownership of that space and want to ensure that we educate everyone when they come in. These are the hazards. Here's the controls. Don't stand there. Don't go over there. Here's your communication points. All of that sort of stuff. But yeah, any good drilling company should have a clearly marked drill site. So entry should be funneled in from one location, not just coming in from all angles. I've had people in the geotech space and things and enviro space walking dogs up to me and talking to me at the drills. It's quite bizarre. There's funny different scenarios you find yourself in. Signage and barricading, it sort of goes hand in hand with delineating your site. Yeah, provide an induction to anyone who enters the drill site. That's just our company policy, to educate people on where they should and shouldn't go. It should be your first step in entering a drill site is get an induction on the drill site. And if you don't get one, guys, you're well within your rights to ask for one. Okay, it's the first step, day one type stuff. Okay, you'll see. Rona, if you can see that there, I've had the pleasure of working alongside Rona in a past job. But some drill sites are better than others. And in saying that too, this site here, that's the current site that we're on at the moment. We're drilling on the toe of a tailings dam. It's sunshine, it's beautiful, it's grassy, it's fantastic. We're just left to our own thing. But under the surface there, we've got some pretty seriously contaminated materials there that we need to look after, and our people that we need to look after as well. So all is not what it seems there. Whereas you move into this site here, this was a recent helicopter job that we did not far from where you guys are at the moment, and it looks chaotic. And to be honest, it was a little bit chaotic, but we identified what the hazards were. We've put controls in place around those hazards, and we abided by those controls, and we executed the job without any incident, injury, and ultimately it was pretty successful. But yeah, it was a 10 by 20 pad. Everything was helicopter lifted in and out. It was noisy, it was windy, it was cold. It was, you can see the return fluids here. It was saturated. We had to walk in, and yeah, it was challenging, but we were up to that, and we got the result, which was good. I'll just refer to my notes just quickly and make sure. Yeah. So sometimes it looks like sunshines and rainbows or skeletons and scarecrows, but you scratch beneath the surface and you identify the hazards, put the controls in place, and then you execute the job. Okay. Excuse me. I'll just move this down. Okay. So drilling methods for mineral exploration, and this is what I've predominantly seen. There may be more out there, but this is what I have dealt with myself, and they can be broken down into categories of air, mud, auger drilling, and sonic drilling, and with diamond coring as well, but that falls into the mud category. So with that auger drilling, there's hollow stem augers, which you can actually sample down hole with, predominantly used in the environmental space with me. I've never used them in Minex, but in saying that, it's a drilling method that is at your disposal. In saying that too, there's also solid flight augers. Ultimately a great big corkscrew, screws down, spews your sample out at the top, and you shovel that away, bag it, sample it, jar it, whatever you want to do, or pull out and do push tubes and SPTs and other various sort of downhole sampling in that hole, as long as the hole can stand up and allow you to get to bottom. Then there is rotary mud drilling. Okay, so that one there is pretty self-explanatory there. Used a lot offshore as well, used a lot in the water bore fields as well as in mineral exploration. This is a big one. Seen lots of nice photos of core this morning as well. So your diamond coring, so your NQ, HQ, PQ3, so your triple tube stuff, which is your wireline. You can go down, pull your tube out, load another tube, keep drilling. There is also conventional, which means you drill your run, you pull everything out, take your sample, trip back in again. So not as efficient, but still it is used from time to time. Then moving into the air family of drilling, I suppose, whereas your rotary air blade, that's a pretty popular one in particular. I know a lot of rotary air done out in Western Australia. We often work alongside a lot of rotary air contractors, and they absolutely smash out the meters and very, very popular in the Minex space, as you guys would already know. There's also air for downhole hammer, or DHH is our abbreviation for that, which is a pretty efficient way of drilling in solid rock. I'll break that one down a bit further. Then there is the RC in the air family, so the reverse circulation with your bit, or there is also reverse circulation downhole hammer. Then also, finally, there is sonic drilling, which I guess in the drilling industry is probably the new kid on the block, although it has been in Australia for about, I'd say, nearly 15 years. Right. Okay, I've got a quick video here, guys. There might be some pickups that you might get out of this. It goes through about, I think it's about 6 minutes, so just bear with us, go through it, and then I'll come back to you once that's complete. Sorry, guys. So there appears to be a lack of audio on my video clip here, guys, but this is ultimately downhole hammer. The cuttings are raised, air's introduced down the drill string, and then brought up to surface. It's pretty simple and fast method, and yeah, so pretty common effort there. You can see the impact of the hammer down the bottom there, smashing all the rock up and then getting cleared up externally, and that's what you see, the dust coming up and outside the hole. This one's a bit more complex, all right, RC or reverse circulation. It's a dual wall rod, quite heavy, these rods, so your delivery air is sent down and then it's actually sucked back up through the bit and through that inner tube there, and then that's actually delivered up hole into your cyclone, and then that delivers a more accurate sample as opposed to the sample coming up out the sidewall of your hole. These are the regular sort of bits that would use on the end of the hammer. Air comes down the outside and then gets sucked back up the inside. So RC is certainly a much more accurate way of sampling as opposed to the regular air core, which is also an effective method of drilling, but the sample quality is just a bit different. So yeah, this is going back to the regular RC. You can see how it's traveling up. It can pick up the passengers, or it can pick up what I call passengers, but it can pick up excess on the outside and contaminate your sample ultimately. And these are some hazards up on site as well. There's plenty going on out there, lots of air, lots of heavy lifting and things like that as well. So they're all things that you need to consider. That hose that's showing there, that's carrying all your cuttings and everything like that. So lots and lots of high pressure air and dust to deal with on that site. Okay, so that's ultimately it, guys. And I'm disappointed that the audio hasn't come through. I'm sorry, but I hope that explanation there and that visual has helped you understand what it looks like. There's the sampling device there as well in regards to cyclones and yeah, your small assay bags and then your bulker samples. Okay. Sorry guys, to move on again. Yeah, that didn't quite go to plan. So we'll move into the rotary mud family of drilling. So instead of air being circulated down your drill string, there's a mix of water as your base fluid that you use. Then you add other additives to that water, and you add either polymers, bentonites, or sometimes you can add foam to that as well. Or foam can also be added back in the air family as well to lift your cuttings up hole, I should say. But yeah, the polymers and bentonites are added to certain mixtures depending on what the requirements are of the strata. But then they're circulated down the hole via the onboard pumps that are on the drill. And these pumps can produce upwards, you know, the ones we've got on board, they can produce 1,000 PSI. So there's some pretty serious pressures and things. So if you do get blockages downhole, your system can be energized up to and beyond 1,000 PSI. So that's some pretty serious pressures. But muds are used to stabilize the sidewall of your hole, cool and clear your cuttings at the bit face and bring them back to the surface for sampling. But similar to the air drilling method where your sample's carried up the outside of your hole, it can pick up some passages on the way up. So sample can be contaminated, or a sample is, I guess, contaminated by the mud. So you need to wash that sample out and do what you guys do with that. And then also there's other cuttings and things that you can pick up that also get transported up the hole as well. So we need to be able to decipher what's accurate and what's inaccurate. But you can see some of the bits here. So this is a PCD bit. Then you move on to some rock roller bits. And I think they're predominantly. Then there's step bits as well. All of these have different applications and different formations. So that's where we're going with those ones. I'll just head down. Okay, another one as well is you've got your auger drilling as well. So this one here, it's probably the most hazardous drill string that I've used in my time. But look, it's a relatively cheap method and pretty common method as well. So this little picture that I've cropped off the internet there is of an American guy, because you can always tell when it's generally Americans, they have no rotational guards around their drill strings and things, and that's just how they operate. A lot of American driller buddies of mine laugh at us with all our cages and things like that. So safety is at the forefront of drilling in Australia. But in saying that, it's ultimately a big corkscrew that goes down and then it brings your sample up to the top. It's a high torque drilling method with a low RPM. So it's not a high RPM sort of drilling method like you would get with something like diamond coring. Bulk sampling can be obtained with augers depending on the diameter that you use. I guess one of the weaknesses of augers is that they can refuse on rock and boulders as well, which can pull your hole up short if you do find some floaters or there's an unexpected change in strata. Generally fairly shallow depth capacities compared to, I guess, other drilling methods. I suppose the deepest I've augered is maybe 25 to 30 metres, and that's a lot of torque and that's a lot of cuttings up on surface and things like that as well. But that's ultimately auger drilling. There is a lot of horror stories with the old auger drills as well. We've heard that's why loose clothing is no good, and also loose hair and things like that as well. Ponytails or hair tied back up in a barn or whatever it is behind your hard hat, and just don't get too close to them because they will bite. This one here, I wanted to given how the last video went, I don't want to flip over and show you a sonic drilling video, but here's some there's some basic sample. We pulled that out of the ground yesterday. So that sample you're looking at there is a fly ash that this particular toe dam's been constructed out of. So that was just some fresh stuff from yesterday. So sonic drilling, it's the way what sonic drilling is that ultimately two weights up in the sonic head, they're about the size of Coke cans, believe it or not. But yeah, just full steel, 3 kilos each or 4 kilos each. They're spun around at about 7,000 RPM. And what that does is actually creates resonance, and that resonance is transferred down the drill string. So we drill completely dry into the formation, and that sample's actually captured inside the core barrel. Then what we do is wash casing over the top of that core barrel, which is a reverse thread, and then we pull the sample out and we extract that and present it as you see here in the core trays there. But yeah, sonic can offer great sample in challenging ground, whereas conventional methods may struggle. So things like lots and lots of mineral sands with sonic, river cobbles and things like that, paleo channels, things like that, where there's high chance and high probability of collapse in the hole as well. We can stabilise the hole and continue to advance. It is a conventional method too, guys, which means that you drill your core barrel down, you case it, then you pull your core barrel out of the hole. So you do need to cycle in and out of the hole each time. Maximum depth range for sonic, it becomes a bit impractical after, around 200 to 250. Sorry, that's a bit deep. No, the deepest hole that's been drilled in Australia is about 232 meters, and that's where it sort of tops out. The cycle times get too much. And yeah, that's where sonic's, I guess, on its limit. Very high sample quality and detail in unconsolidated strata. It can be more expensive compared to other methods. However, what we've discovered on a job recently up in New Guinea was that it was a tailing storage facility investigation. There was about $10 to $12 million spent on a diamond drilling program to try and do a feasibility study, but unfortunately there was about 30 to 35% core recovery for that program, and they needed more results. So someone in the room stuck their hand up and said, have you tried sonic drilling? We got engaged for that, went up there. We ended up drilling 150 meters of river cobbles with any 97, 98% recovery. So it was a little too late, but yeah, it certainly moved where they were going to build their tailings storage facility. And yeah, so we never hit basement rock on that particular job. But yeah, sonic, it's don't put it in solid rock. All right, it's not something that you use. Diamond drilling is the preferred method there. Absolutely, we can drill rock, but it's just nowhere near as high a quality. But if it's challenging crap ground that conventional is struggling in, well, that's where sonic, I suppose, excels, that we've found. I'll just go down here. So yeah, I don't want to go too far over time either, guys, but the teamwork between the drillers and geologists, okay, things you should know as a new geo out on site is that when you first get there and team up first day on site with the drill crew, communicate your objectives clearly, okay, what your sampling requirements are, depths, all that kind of stuff, whether there's any orientation and things like that. Just it's all about communication from the get-go, and it sets the tone that there's an open channel of communication between geos, drillers, the whole lot. It really does set a good tone for the project. It's nothing worse than being on a project where it feels like there's this us and them kind of scenario. It's just unproductive and it's detrimental to the project. But yeah, communicating the overall project targets. Another good thing that I really like is contribute on site where possible. Just if you've got a little workstation there, don't just walk away from it and expect someone to pack it up for you. Just pack your area down and just have it ready to move, or even load it into your ute and let's move to the next hole. Okay, just little things like that really help out, and it helps build rapport with the crew. All right, be prepared. Bring the tools you need with you onto site. Okay, and then in saying that as well, There's some common issues I've seen and some guidance that I would offer as well. So don't leave site without communicating with the driller, in particular in isolated locations, okay? Just a quick one, hey, I'm leaving site, I've just got to duck to the office, I'm coming back, or I'm done for the day, you won't see me, I'll see you at camp. That's cool, whatever it is, as long as that's clear, as opposed to if you just leave and the drill crew's like, okay, where's the geo, what's going on, things like that. So just something there to take on board. Not being on site when required can be frustrating as well. We could hit a junction in the hole that we need some guidance on. So just make sure that you're contactable if you are off site. Engage with the drillers too, or the drill crew. Ask questions about drilling. Learn about the machines, learn about the tooling, things like that. Share your knowledge of the formations in the area, and that can help us make better choices in regards to bit selection and drilling techniques as well. Learn about the drill rigs as well, different makes and models and everything like that. There's a lot to choose from out there. The most beneficial interactions I've had through my drilling time has been learning the technical lingo of what you guys are looking for, and learning how you describe what the formation is. It helps us become better drillers, and it helps us become better communicators when maybe not on that job, but the next job, and helps us grow and develop. But most of all, respect each other out there. We're all experts in our field, and we both need each other to complete our tasks out there as well. And the last one here is some quick resources here, guys. There's a bit of a structure that we work through. We do have, I'll start over here, is there's certifications in drilling all the way up to diplomas. We also sit well screens and gravel packs courses. There's industry bodies out there like the ADIA, that's our governing sort of body, along with the individual states water corporations and things like that. There's registered training organisations out there for us drillers and our offsiders. I'd highly recommend looking into Bort Longyear drilling tools. They're probably a market leader in a lot of tools, in particular diamond, but then you've also got Atlas Copco for air tools or diamond tools. You've got Sandvik as well. In regards to the muds, you've got AMC, Australian Mud Company, and there also is a certificate in muds as well, which we do as well when we become waterbore drillers. Other drilling resources here, we've got minimum construction for waterbores in Australia. Not that that really applies to Minex, but it's a good reference. There's the drilling manual, which I have here. It's the biggest, fattest book I've ever owned, but it is fantastic. I always have that with me. There's the Australian Drilling Institute app, which is a little picture down here. I highly recommend, if there's one thing you guys take away today, get this app, put it on your phone and just have a play with it. It'll give you a reference to lean on if you're not sure in regards to what the driller's doing. So it's a great reference. So get that. Oh, there it is down the bottom there. There is also another one called My Swaco, which please download it, check it out, because our drillers are using it every day. It's fantastic. I think I might have gone a little bit over time there, guys. Is that my lot done? I'm not sure. Sorry. Yeah, I reckon I'm done actually, but that's the last page in my presentation anyway, guys. So hopefully you made some sense out of it. Apologies for the technical issues. As far as the presenter goes, I make for a good driller. So I'll let you guys go. Thanks very much for having me.